Hello everyone, my name is Josh and welcome to today's video on proportion. Now I'm going to go through the two types of proportion today, direct and inverse, that you need to know for GCSE maths. So proportion is quite a useful feature in maths. We can basically use it if we know two values and know whether the two variables are proportional to each other or not. We can actually form an equation just from knowing one of each of the variable's values. So just from any two values and knowing something is either direct or inversely proportional, we can form an equation and work out any value. So the first thing I'm going to go through today is direct proportion. Now, if two values are directly proportional to each other, we write it like this. So if A is directly proportional to B, then this means that for an increase in B, there will also be an increase in A. So if you had a graph of A against B, it can be anything linear in B, a linear increase in B. So it can be this shape, this shape, this shape. It can be anything as long as it involves a linear increase in B. If it wasn't a linear increase in B, this would say proportional to B squared or something, and then it'd be parabolic. But yeah, so for direct proportion, it's written in this format, which means A is proportional to B. For example, if you have an equation instead of a proportionality, y equals 2p, this can also be shown as a proportionality relation, where y is proportional to p, like that. Now, in this case, you have a constant of proportionality. So a constant of proportionality is what factor makes the two relate. So in this case, our value of k, this is proportionality constant, is 2. So if you can find a constant of proportionality, it allows you to turn a proportionality relationship into an equation. So quite often that will be what they ask you to do in these questions for GCSE level. So let me draw this line. Say for example, you need to know, you've got two two variables. You've got E, which you know at one random point is equal to 20, and P is equal to 10. Now, at these values, we're told that E is directly proportional to P. So we know it's directly proportional at these two values. And what we want to do is find an equation relating E to P. So that's what the question has given us and what it's asked us to do. So what we know when it comes to this, we know that E is proportional to P like this. Now, in order to form an equation, we need to find the constant of proportionality. So what gets us from this 10 of P to this 20 of E? So in this case, we have E is proportional to, I tend to just call it K as our proportionality constant, but you can call it any variable you want as long as it's not already used in the question. If they give you K, use something else because it's just going to confuse you and your examiner. So we know that E is proportional to K at these two values. So what that means, if you turn this into an equation form, 20e, oops. So you want to turn this into an equation form by finding this proportionality constant. So E proportional to Kp indicates that E is equal to Kp because we have a value of each at the same point. So like we know that they're directly proportional at these 2 points. That means that something has happened to P to make it the value of E. So that means we can go from a proportionality relationship to an equation like this. Now we sub in our points like so 20 equals 10k, so we have that, and then we can quite simply solve that. K equals 20 over 10, which equals 2. So that's our proportionality constant. So that means our equation overall is E equals 2p, like that. So we have our equation now, E equals 2p. So it might tell us to find another value of E, just to test that you've definitely got it right. So for example, it might say now find E at P equals 12. Just give you another random point and it wants you to find the value of E. Well, we just sub that straight into our equation. So E equals 2 times 12. So E equals 24. And that's quick, easy marks. Because once you know, if you can do this step and then substitute in your values correctly, you've basically solved the question. So direct proportionality is very straightforward. You just need to state a proportionality factor in, sub in your 2 values, and you're there. So I'm also going to go through inverse proportionality. So inverse proportionality is similar to direct proportionality, but the proportional relationship we form is slightly different. So if we know that, for example, B is inversely proportional to M, then we write it as B is proportional to 1 over M. So this is the only difference between direct and inverse proportionality. Whereas direct is would be B proportional to M. Inverse proportional means B is proportional to 1 over M, because this inverse part of the word would literally mean M to the minus 1 or 1 over M. So you just got to remember that B is proportional to M for direct, and B is proportional to 1 over M for inverse. So in this case, B is proportional to 1 over M. So we will likely be told to do exactly the same thing. So if I just give you a quick answer. So in this case, the way we can do it, so if we have an equation where y equals 36 divided by x, like that, and we're also told that at this point y is equal to 8 and we want to solve for x, then we just do x equals 36 over 8, which equals 4.5. So this is an example of an inversely proportional equation. It's y is proportional to 1 over x, and your constant of proportionality, k, is equal to 36. So we're now going to use this to form an equation from an inverse proportional relationship. So we're told that G is equal to 4 and W is equal to 9. And at this point, G is inversely proportional to W. So we know that that means G is proportional to 1 over W. Now, obviously, 9 does not equal 4, so that means there is a constant of proportionality in this. If it was like 4 and 4 here, the constant of proportionality would be 1, because it's just whatever you need to do to one to get to the other. So if they're the same, it's just times it by 1. But here it's not, so we say G is proportional to K over W. Just K is our constant of proportionality that we're timesing by 1 over W to get to G. So so we've got this. So we want to do as before, G is equal to K over W, because we know two values are at the same point, are inversely proportional. So then we want to solve for K. So we get K is equal to G times W, and that is equal to 4 times 9, and that is equal to 36. So that means our overall equation for G and W is G is equal to 36 over W. So that's our equation, which we've been told to calculate. Now, again, we're going to find a value of G at W is equal to 6. So we've just been given another point of W, and we want to find a value of G for it. So G is equal to 36 over W. We sub in our value of W, that means it's 36 over 6, and that means our value of G is equal to 6. So these questions, they may seem daunting at first, but once you get your head around the concept that it's literally just form an equation of y equals kx for direct and y equals k over x for inverse, then it's just a simple matter of substituting in and rearranging. So I'll go through one more example of each just to make sure you fully know what's going on, and then have a go at some examples yourself, and you should find that if you follow this method, you'll get the right answer. The next question I'm going to go through, just for an example, is we will say that R is directly proportional to S, and we know it's directly proportional at a point where R equals 9 and S is equal to 1.5. So S is equal to 1.5. So we know at this point they're directly proportional, so what we can say is R is proportional to S. So that means that R is equal to KS. So we know our two values, so we need to rearrange for K. So K equals R divided by S, which equals 9 over 1.5. 9 divided by 1.5 is equal to 6. So that means our equation is R equals 6S. And that's it, that's our equation. So we also need to find, I might just change variable to make that look a bit clearer, because S looks a lot like 5. So I'm just going to go through and just change out these S's for Z's, but the method hasn't changed. I'm just changing what the variable is. So this is z, this is z, 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 z. Oops, no, not z there. Z. There we go. So the method didn't change at all. I just swapped out the s's for z's to make it clearer. So we also want to find r at z is equal to 8. Oops. At z is equal to 8. So that means that r equals 6 times 8, and that is equal to 48. Now I'm going to throw another little one in here, just quickly. So find z at r is equal to 15. Now, there's no need to worry, it's just simply rearrange that equation that we've derived and we'll get straight back. So we want to find a value of z this time, so it's z equals r over 6, and that is equal to 15 over 6, and that is equal to 2.5. So there's all the answers to that question in just like a minute or so of working. I forgot to fill in a z there. So this style of question can be a very good way to score a few extra marks if you just follow through the method like this. So I will take you through one more inversely proportional question, and that will do. So the final question I'm going to go through tells us y is inversely proportional to x squared at the points y equals 2 and x equals 3. So it wants us to find an equation of y in terms of x. So all we need to do this time, we say y is proportional to to k over x squared. So we say y is equal to k over x squared. So k equals yx squared, which equals 2 times 3 squared, which equals 18. So if we write out what our equation is, it's y is equal to 18 over x squared. So that's our final equation for y. And now we want to find another value of y. We'll say when x is equal to 5. So find y when x is equal to 5. So all we do, y is equal to 18 over 5 squared, which equals 18 over 25, and that is equal 0.72. And that's our final answer. So there we go. That's everything I'm going to go through in this video today. Regardless of what your equation is, if you follow the same method, you will be able to find out of an equation and solve it for another value. Like if it says proportional to x plus 3, for example, then you just do the same thing but with x plus 3 instead of z here, or inversely proportional, you do proportional to k over x plus 3 there. So whatever it is, just remember to do, for direct, you want to do y equals kx, and for inverse, you want to do y equals k over x. So as long as you do that, you should be fine with any question they can throw at you. So that's going to be it for this video today. Thank you for watching. I hope you found it helpful. If you have any further questions about this topic that you'd like me to answer, just comment them down below or get in touch with me through some form of social media. If you have any more video topics you'd like me to cover, just contact me again via the same means. So thank you again for watching, and I hope to see you next time.